Yes, welcome you all for the today classes. Today we are going to start the new model, that is the fluid dynamics. Okay, so in these classes we are going to start some basics about the fluid dynamics. Okay, so let's start this class. First, uh, what is this fluid dynamics? The fluid which is in motion, the fluid which is in motion, and we are considering some forces that we call it as the fluid dynamics. Dynamics is nothing but it is the fluid dynamics is nothing but the fluid is it is in motion, and we are in that motions we are considering some forces that we called it as a fluid dynamics. Okay, so there are some forces acting on the fluids. What are those? Following are the forces acting on the fluids. What are those? Now we have to see here. So first one is the self weight. So that is the first forces which is acting on the fluid, that is the self weight. And pressure force, second one is the pressure force which is acting on that fluid flow. And third one is the viscous force that is indicated by Fv, and fourth one is the turbulent forces that is indicated by the Ft, and the fifth one is the surface tension forces, and the sixth one is compressibility forces. So these six forces are acting on the fluid while it is in motion conditions. Okay, so first, what is the fluid dynamics? Fluid dynamics is nothing but it is the motion of the fluid. Okay, motion of the fluid, and we can consider some forces while studying, while analyzing the fluid is it in motion, and also we can consider some forces to analyze the fluid. So and those forces are some forces are acting that fluids. Those forces are, the first one is the self weight, pressure force, viscous force, turbulent force, surface tension force, and compressibility forces. Okay, so now dynamics of fluid is governed by the Newton's second law of motion. Okay, whatever this dynamics is there, the dynamics of the fluid is governed by the Newton's second law of motion. Okay, so what is the statement of this Newton's second law of motion, which states that the resultant force on any fluid element, the resultant force on any fluid element must be equal to the product of the mass and acceleration of the element. So that is indicated by the summation of F is equal to ma. So once again we can see that statement of the Newton's second law of motion. Okay, which state that the resultant forces, the resultant is nothing but the sum of all the forces which are acting on the fluid, sum of all the forces which are acting on the fluid. What are those forces? See here, these are the forces which are acting on the fluid, flowing fluid. Okay, sum of all these forces we can call it as the resultant forces on any fluid element must be equal to, the resultant of all these forces must be equal to the product of mass and acceleration of that element. So mathematically we can say that summation of F is equal to ma. So already we bothered about this equations. Okay, summation of F is equal to ma. Summation of F is nothing but the resultant force which must be equal to product of mass and acceleration. Okay, that is this law is governed by the dynamics of fluid. The dynamics of the fluid is governed by Newton's second law of motion, which state that the resultant force is equal to must be equal to product of mass into acceleration. Okay, so now what are the force which includes here in the resultant force? So these are the some forces which are included in this resultant forces. Okay, now if the surface tension forces and the compressibility forces, means the surface tension forces and compressibility forces are not significant, these are not the significant one and may be neglected. If these two forces are not significant in the fluid forces, so we can neglecting these two, we left with these four forces that is given by here. It is, if you are taken, this is equation number 1, then the hence the equation 1 becomes this resultant force is equal to what? Fg plus Fp plus Fv plus Ft. That means Ft is nothing but the self weight, Fp is nothing but a pressure force, and Fv is nothing but the viscous force, and Ft is nothing but what? Turbulent force. The resultant of all these forces, that is given by the summation of F. So that is Fg plus Fp plus Fe plus Ft. Okay, the fluid dynamics of the fluid is governed by the Newton's second law of motion, which state that the resultant force must be equal to the product of mass into accelerations. Okay, okay, and we know the some forces which are acting on the fluids. What are those? So all these six forces are acting on that fluid flow. So in that, if the surface tension force and the compressibility force is neglected, okay, if you are neglecting because of they are not a significant one, so we left with these four forces which gives the resultant forces, that is Fg plus Fp plus Fv plus Ft. So here Fg is nothing but the self weight, Fv is nothing but the pressure force, Fp is nothing but the viscous force, and the Ft is nothing but turbulent forces. Okay, so here next, uh, okay, so Reynolds equation of the motions and used in the analysis of turbulent flows. So this is the Reynolds equation of motions. This is the Reynolds equation of motions and used in the analysis of the turbulent flows. Okay, and there are two types of flows. One is the turbulent flows and the other one is the laminar flows. So this is Reynolds number is used for the analysis of the turbulent fluid flow. Okay, for laminar flows, again for laminar flows, turbulent force becomes less significant, hence one becomes. Okay, so for turbulent flows, we can take these all forces. Okay, and for laminar flows, this whatever this turbulent forces is not a significant. Okay, so you can left this, you can left that. So we left if you neglecting this turbulent forces, we keep it this t. Okay, that is summation of F is equal to Fg plus Fp plus Fv. Okay, so this is the Reynolds equations for the laminar flows. Reynolds equation for the laminar flows. Okay, so Navier-Stokes equations if viscous forces are neglected. So if you want to get the Navier-Stokes equations, then you can neglect the viscous forces. What are those here? So in these equations, you can neglecting this viscous forces. Okay, then this equation number 1, it reduces to summation of F is equal to Fg plus Fp. So if you are neglecting this term in the Navier-Stokes equations, and we left this summation of F is equal to Fg plus Fp. Okay, so here equation 1 reduces to summation of F is equal to Fg plus Fp, which is equal to Ma. That is here summation of F is equal to Ma. This summation of F is nothing but what? Fg plus Fp. If you are neglecting the turbulent forces, then it is the Reynolds equation for the laminar flow, and if you are neglecting the viscous forces, then it becomes what? Navier-Stokes equations. Navier-Stokes equation, that is summation of F is equal to Fg plus F is equal to m into a, that is mass into accelerations. Okay, so this we called it as a Euler's equation of motion. Euler's equation of motion. Okay, so next we go through some Euler's equation of motions. What is that? Here consider a streamline in a flowing fluid in s directions. Okay, so here consider a streamline of in a flowing fluid in s directions as shown in the figure. On this streamline, consider a cylindrical element having the cross sectional area dA and length ds. Okay, see here, if you are consider one streamline here which is flowing in this s directions, this is the s directions. Okay, so if you are consider one streamline which is flowing in the s directions, in that we are considering one small element which is having the length of ds, and the area dA and area dA. Okay, so consider one streamline which is flowing in s directions. Here this is a s directions. Okay, and in that we are considering one small element. That element is having the length of ds and the area dA. So this is the figure. Okay, and here forces acting on the elements are pressure forces at both ends. So this is one end and this is another end. Here the pressure forces, these two are the pressure forces acting on the both the ends. Okay, uh, so here first pressure force PDA in the direction of flow. So here the streamline flow directions. So here this PDA is the pressure forces in the direction of flow, streamline flow, and this pressure forces P plus rho P by dou P by dou S into ds into dA in the direction opposite to the flow direction. So this is the another pressure forces which is acting at other end. Okay, so these two are the forces which are acting in opposite to each other, which are opposite to each other. One is the pressure forces which is acting along the direction of the streamline, and the another one is the pressure forces which is acting opposite to the streamline directions. Okay, another one is the weight of the element, that is P dA ds acting vertically downward directions. This is the weight of the element. This is rho g dA ds. Okay, so that is the rho dA ds acting vertically downward direction. So in this elements there are three forces which are acting on that element. One is the pressure forces in along the direction of the s directions. Another one is the pressure forces opposite to the direction of streamline. Okay, another one is the self weight. Okay, which is acting downward directions. Okay, now let phi be the angle between the direction of flow. So this phi is the angle between the direction of flow and the line of action of the weight of the element. This is the weight of the element, line of action of weight of the element. This is weight of the element. So this phi is nothing but the angle between the pressure forces, angle between the flow, direction of the flow. This is the direction of the flow and the self weight which is acting on that element. This is the angle here. Okay, the resultant forces on the fluid element in the direction of s must be equal to the mass of the fluid element in the acceleration in the direction s according to the Newton's second law of motion. Okay, the resultant force summation of f is equal to ma. Summation of f is equal to ma. So here first we can take the forces which are acting on that which are acting on this element. So there are three forces which are acting on this element. One is the pressure force at along the direction of the s direction. Another one is the pressure forces at this end which is opposite to the direction of the flow. Another one is sulfate. So now the resultant forces is nothing but the summation of all these three forces. Summation of all these three forces are called as a resultant forces. That is what here he has given, that is the PDA. This you can take the positive sign because it is along the direction of the stream flow, plus minus PDA here, these forces, minus P plus dou P by dou S ds dA. Okay, in which is opposite to the streamline direction. That's why you can take it as a negative here. This is the negative sign. It is the positive sign because it is along the direction of a streamline flow. And the another one is the minus rho g d cos phi is equal to, another one is the rho g dA cos phi, because we can take that angle. It is that this weight of the element is acting with some angle with respect to the direction of the flow of streamline. Okay, so it will make some angle with respect to this line. So you can take that minus rho g dc. Why it is minus? It is in opposite to this line of direction. Yes, okay, that's why it is minus rho g d cos phi, which is equal to rho dA dsa. Yes, okay, rho dA ds is. So what is this? This is the mass into acceleration. This as, small as, is nothing but the acceleration, and rho dA ds is nothing but the mass. Mass is equal to what? Density into volume. So this is the uh, density is nothing but rho dA ds is nothing but a volume. dA is the area into length, that is volume. So dA ds is gives the volume, that is the area. Okay, this is ds, this is volume into density is the mass into acceleration, this small as is the acceleration, this is the m into a. So this is the resultant forces which are acting in this element, small element. Okay, so here you can take this equation number a, small a. Okay, where as, the small as is the acceleration in direction of s. Okay, acceleration in the direction of s, this small as. Okay, and this is the mass into acceleration. Okay, mass is equal to what? Density into area. Area is, density into volume, sorry, density to volume. Volume here dA is nothing but area into length will gives us the volume. Okay, where as is the acceleration in the direction of s. Now as is equal to dv by dt. As is equal to what? Dv by dt, where v is the function of s and t, where v is the function of s and t. So for that we can write that dou v by dou s into ds by dt plus dou v by dou t, dou v by dou t. Okay, so here again we can write that v into, sorry, we can remove this term ds by dt here. V into dou v by dou s only, we can write only v dou v by ds. So this is the term which is by mistake it is given here, plus dou v by dou t, plus dou v by dou t. Okay, next, where since ds by dt is equal to v, since ds by, so this ds by dt is equal to v and dou v by dou s is as it is, so we can remove this term here plus dou v by dou t. See here, since ds by dt is equal to v, if the flow is steady then dou v by dou t is equal to 0, this dou v by dou t is equal to 0 if the fluid is in steady state conditions. Okay, hence as is equal to, hence this as is equal to, this as is equal to what? Here as is equal to v into dou v by dou s, v into dou v by dou s. Okay, this uh, we left with only what? As is equal to d into v into dou v by dou s, dou v by dou s. Okay, so again we have to substitute all these values in the equation, equation a. Okay, in the equation a and simplifying we will get that. See here, this is the equation number a. So this pda minus pds get cancelled, this minus is multiplied here, dou p by dou s into ds da. Okay, and this minus rho gd cos pi is equal to rho da ds as. So that is given here. So minus dou p by dou s ds da minus rho g ds da cos phi is equal to rho da ds into as is nothing but what? This as is equal to v dou v by dou s. Dividing whole equations by, dividing whole equations by rho ds da, rho ds da. So we will get that minus dou p by dou s plus g cos phi, because we divided this rho ds da. Okay, we left to rho rho cos phi, rho sorry, g cos phi is equal to v dou v by dou s. We divided this term in all these three terms. Okay, this is what we left with. So we can simplify it, dou p minus term, just we have to neglect, take out the minus term, dou p by dou s, dou p by rho dou s plus g cos pi g. So just you can take this term. If you are taken this minus term outside then it becomes minus, so if you are taken this term to this left side then it becomes positive. So that rho dou p by dou p rho dou s plus g cos phi plus v dou v by dou s is equal to 0. But from the figure we have cos phi is equal to dz by ds. So just we can substitute this cos phi in here, dz by ds. Hence 1 by rho, here this is 1 by rho dou p by dou s, 1 by rho dou p by dou s plus g into, so cos pi is nothing but what? Dz by ds, dz by ds plus v dou v by dou s is equal to 0. Or you can simply write dou p by rho plus g dz plus v dv is equal to 0. If you are taken this term common and make it move to this side, it becomes 0. Rho p by dou p by rho plus g dz plus v dou v is equal to 0. You can take this equation as a b. Okay, so this equation b is known as the Euler's equation of motion. This is very important equation. So that rho b by dou p by rho plus g dz plus v dv is equal to 0. This is the Euler's equation of motion. Okay, so with this we can completed the today classes. Okay, so we will start the next topic in the next videos. Okay, thank you.